Good morning children. Previous classes we were discussing about the equilibrium. What was equilibrium? We had discussed physical equilibrium, we had also discussed chemical equilibrium and the various factors which are affecting the equilibrium constant K, how to represent K, how to write K for a reaction, all that we have discussed in the previous sections. Today we will discuss the type of chemical equilibrium. Okay. We had discussed the type of physical equilibrium, similarly the type of chemical equilibrium. Today that topic we will take and try to express the equilibrium constant for a given reaction. Okay. So, these two things we will do it today. So, when we say types of chemical equilibrium, there are two types. One is homogeneous equilibrium and other is heterogeneous equilibrium. Now, what do you understand by homogeneous equilibrium? Homogeneous meaning the reaction is carried out in such a manner that the reactants and the products both are in the same phase. That is, we can say that all the reactants and the products are in the same phase. Say for example, all of them are gaseous in nature, the reactants also and the products also, then it is gaseous in nature. Or we can say the reactants, products, they are in liquid phase. So, that kind of a reaction and equilibrium being established in that reaction, we call that kind of chemical equilibrium as homogeneous equilibrium. Various reactions we can see. See H2 plus I2, these are all the reactants and the products, they are in the gaseous phase. Here also you will find that reactants, products are in the gaseous phase. We can also see the reactions where you will find the reactants, products both are in the liquid phase. Say for example, ये जो है ना the formation of an ester, okay, यहाँ पे you will find all of these, no, they are reactants, products in the gaseous phase. Okay, reactants and products are in gaseous phase. You will also find these are also, they are all gaseous. Okay, you can represent it this way. N2 is gas, O2 is gas, NO, nitric oxide which is formed, that is also gas, carbon monoxide, steam giving you carbon dioxide and hydrogen being released, all of them are gaseous product. Here also you will find all of them, the product reactants are in the gaseous phase. You will also see where the reactants, products, they are in the liquid phase, that is CH3, CH2, OH. ये क्या हो गया? This is ethanol, okay, which is liquid form. Even acetic acid, ये CH3COOH क्या हो गया? Acetic acid. They both are in the liquid phase, okay, and they react to give you ester, that is CH3COO, CH2, CH3 plus H2O is also released. So, here also you will find all of them are in the liquid phase. So, this is an example where you can see all the reactants, products, they are in the liquid phase. Here they are in the gaseous phase. ऐसे जो equilibrium होते हैं, equilibrium establish होते हैं in the reaction, it is known as homogeneous equilibrium. ठीक है? तो ये सारे जो है, these are all gaseous reactant, gaseous products, H2 plus I2 giving you 2HI, N2 plus O2 giving you 2NO, carbon monoxide plus steam giving you carbon dioxide and H2. ये सारे reactions में you will find that delta Mg will be equal to 0 because number of moles of products and number of moles of reactants, they are equal. तो ये सारे examples में you will find that delta, here you have delta Mg equal to 0. Here you will find that delta Mg is not equal to 0. It may be positive, it may be negative. Okay. In this case you will find that it will be negative, it will be positive, okay, because 2 minus 1, it will be 1. In this case it is 2 minus 3, that is minus 1. Here you have 2 minus 4 which is equal to minus. So, here you will find that delta Ng is not equal to 0. It may be positive, it may be negative. Okay. So, delta Ng can be negative or positive. That is how it is. ठीक है. Here you will find that this is the reaction where you can see the reactants products, they all are in the liquid phase. तो ये हो गया तुम्हारा homogeneous equilibria. Then coming to heterogeneous equilibria. Heterogeneous equilibria में the reactants products, they need not be in the same phase, they are in different phases. Say for example, decomposition of calcium carbonate. Calcium carbonate is solid in nature, it will decompose to give you calcium oxide plus carbon dioxide. Carbon dioxide gaseous है लेकिन ये दोनों solid है. Similarly, the formation of water gas, which you have learnt in the S block elements, you have learnt the formation of water gas, isn't it? So C, which is solid, reacts with steam to give you carbon monoxide plus H2 mixture, which is known as water gas. So these are gaseous लेकिन carbon जो है वो solid होता है. ठीक है. Another reaction, Fe reacting with steam, Fe is solid, reacting with steam to give you Fe3O4 solid plus H2 gases. तो यहाँ पे भी you will find two phases, solid and gaseous phase both. तो ऐसे जो equilibrium establish होते हैं in reactions, that is called as heterogeneous equilibria. ठीक है. अब इनका Kc Kp कैसा लिखते हैं, that you should be knowing. Okay. So if you want to write Kc for this particular reaction, how to write Kc? Kc क्या होता है? Kc हमने क्या बोला था? It was equilibrium constant, no? Kc concentration के terms में अगर C लिखते हैं तो concentration के terms में लिखते हैं. It should be the product of the it would be the product of the concentration of the products upon or divided by the product of the concentration of the reactants raised to their stoichiometric coefficient. ठीक है. तो यहाँ पे Fe3O4 प्रोडक्ट हमारा Fe3O4 और H2 है. ठीक है. रेस्ड टू द स्टोइकियोमेट्रिक कोएफिशिएंट मतलब रेस्ड टू 4 हो जाएगा अपॉन यहाँ पे रिएक्टेंट्स क्या है, Fe है, रेस्ड टू 3 होगा और H2O रेस्ड टू 4. तो हमने Kc लिख लिया इस पर्टिकुलर रिएक्शन के लिए. ठीक है. लेकिन जस्ट नाउ वी शुड अंडरस्टैंड कि व्हेनेवर आवर रिएक्टेंट्स आर सॉलिड्स और प्योर लिक्विड्स, तो उनका कॉन्सेंट्रेशन वी ऑलवेज टेक इट एज यूनिटी, एज वन. तो इसलिए हम Fe3O4 कॉन्सेंट्रेशन वी शुड टेक इट एज 1 इंटू H2 रेज टू 4 बाय Fe ऑल्सो इट इज़ अ सॉलिड, सो इसका कॉन्सेंट्रेशन वी शुड टेक इट एज 1 इंटू H2O रेज टू 4. ऐसे होगा. So finally you will get it as H2 raised to 4 upon H2O raised to 4. ऐसे मिलेगा. So this is how it is. If you want to represent the Kp value, then how is your Kp value represented? Kp will be partial pressure only of the gaseous substances. Okay, we will not write it for the solids. Okay, so P again H2 raised to 4 upon P H2O raised to 4. So that is how you represent the Kc and Kp for this particular equation. Okay. Similarly, you can write for CaCO3 and CO. You can write it on your own. Okay. So that will be helpful for you. You can take it as a homework and write it. I have shown you for one of the reaction. You can write it for the other reactions. Okay. How will you write it for homogeneous equilibria? Homogeneous equilibria के लिए भी हम लिख सकते हैं. Suppose for this equation, how to write Kc or Kp? Kc है, this will be equal to Hi, that is product देखने का raised to 2 by H2 and I2. ऐसा होगा. और Kp कैसे लिख सकते हैं? Kp will be equal to P of Hi raised to 2 by P of H2 into P of I2. इस तरह से लिख सकते हैं H2, Kp and Kc. So that is how you can represent the Kc and Kp value for the reaction. Same way you can do it for this. So all of these reactions you have to write the Kc and Kp in your notebooks. Okay, that is a homework for you today. So you will write Kc and Kp representations for these homogeneous equations and for these heterogeneous equations. There are number of reactions you can write for, but for today you take this as your homework. Okay, note it everyone. Coming to application of equilibrium constant K. Okay, uska first application we will discuss to predict the extent of reaction. How much the reaction has been completed. We come to know by looking at the value of K. Okay. So, what do we see? Ki larger the value of K. K ka value, if it is very large, that is greater than 10 power 3, it shows that forward reaction is favored, and therefore concentration of product will be much larger than the concentration of the reactant. Okay. So, you can write here ki therefore concentration of products is much larger than concentration of reactants. Okay, than reactants, because it is favoring forward reaction. That means forward reaction is occurring to a greater extent, that is showing the products का amount will be much larger than the reactant. तो जैसे example H2 plus Br2 giving you 2 HBr, they all are in the gaseous state. This is a homogeneous equilibria. Kc value 5.4 into 10 power 18 means very high value of K. So another reaction, that is H2 plus half O2 at 500 Kelvin giving you H2O. Here you find that Kc value is 10 power 47. So these reactions you will find Kc value is very large, indicating that the reaction is favoring in the forward direction, and forward direction may if the reaction is occurring, that means the amount of product will be much larger than the amount of reactant. That means here the reaction will lead to completion, it will go to completion. Okay. So larger the value of K, more is the forward reaction, and the reaction will be heading towards the completion. Okay. Intermediate value of K means in between value, like K ka value comes between 10 power minus 3 to 10 power 3. This shows that the equilibrium is reaction is at equilibrium, and the amount of reactants and products, they are in a comparable concentration, that is दोनों का almost equal होगा. ठीक है. This is a reaction where Fe plus 3, it is in the aqueous form, Sn, this thiocyanate ion again in the aqueous form, it is giving you the complex ferrous thiocyanate, all are in the aqueous form. This is another example of homogeneous equilibria in the aqueous form. Okay. And here you find that the Kc value is 138 at 298 Kelvin, that is at room temperature. So again this is an intermediate value coming between 10 power minus 3 to 10 power 3. If you just take it as 1.38, then it will be 10 power 2. So it is coming in between them, it is the intermediate value. So therefore you will find appreciable amount of product and reactant. Okay, that is how it is. Now coming to K value, which is very low, that is less than 10 power minus 3. In that case, the backward reaction is favored. Reaction is not going in the forward direction, it is going in the backward direction. अगर backward direction में जाता है मतलब reactant का amount will be more than the product. Okay, so concentration of reactants are more than products. So you can see this equation N2 plus O2 giving you 2NO. This is actually the reaction where nitrogen is combining with oxygen. We are talking about room temperature. Room temperature, do you think N2 and O2 will combine? Because in our air we have N2 and O2. Do they combine? No, they cannot combine. It will not go in the forward direction. It will remain as N2 and O2 favoring the backward direction. उसमें Kc का value is 4.8 into 10 power minus 31. very less. Okay, forward reaction होगा ही नहीं, almost it is nil. So this kind of reactions you find that the reaction is not favoring in the forward direction, it is favoring backward direction, and the amount of reactant is much larger than the amount of product. ठीक है. Similarly H2 plus O2, H2O decomposing into H2 and O2, that also at room temperature, it is not possible. Water cannot decompose into H2 and O2 at room temperature. Can it be? No. That is why Kc value for that comes out to be 4.1 into 10 power minus 48. Minus 48, a very less value of Kc. So therefore, this reaction is also not going into the forward direction, it is going into the backward direction, and therefore amount of reactant is much larger than the amount of product. So by knowing the value of K, we can predict whether the reaction will go to completion or not, or whether it will favor backward direction reaction or it will favor the forward reaction. These things we come to know by knowing the value of K. Okay. So this was the first application of equilibrium constant K. Okay. Note down. The second application of equilibrium constant is in predicting the direction of the reaction. Now how is it helpful? We will just see. See, you take an imaginary equation or a reaction where you have the AA reacting with A moles of A reacting with B moles of B in equilibrium gives C moles of C plus D moles of D. So in that way you have the reaction in equilibrium. Now Kc is the equilibrium constant, isn't it? So Kc will give you the relation of the concentration of the products and the reactants at equilibrium. We have one more term to be known, that is concentration quotient, that is QC. Now this QC, it is equal to C raised to C, D raised to D upon A raised to A into B raised to B. A formula is same, but what is QC? QC is the concentration quotient, that is the concentration of the reactants and products taken at any other time than equilibrium, than at equilibrium. तो इक्विलिब्रियम में हम लोग मेजर नहीं कर रहे, जब रिएक्शन इक्विलिब्रियम में आ जाता है तब हम जब रिएक्टेंट और प्रोडक्ट्स का कॉन्सेंट्रेशन मेजर करते हैं, दैट इज गिविंग यू इक्विलिब्रियम कांस्टेंट. QC क्या है? कांस्टेंट, दिस इज कॉल्ड एज concentration quotient, where you take the concentration of the reactant and product at any other time than at equilibrium. ठीक है, इक्विलिब्रियम में नहीं देखते, उससे पहले वी कैन टेक द वी कैन मेजर द concentration of the reactant and product, and we can represent it as QC, which is given by C raised to C into D raised to, because the product and the reactants are remaining the same only. So the formula is the same, Q C raised to C into D raised to D upon A raised to A into B raised to B. So this is the formula to find concentration quotient. So concentration quotient and equilibrium constant, when we compare, then we can predict the direction of the reaction. How? We will see. If QC concentration quotient, जहाँ पे हमने reactants और products का concentration का measure किया है before attaining equilibrium, then if you find that QC is equal to Kc, then the reaction is in equilibrium. We can predict, or we can say that the reaction is in equilibrium. But if you find out that QC is greater than Kc, that is reaction quotient or concentration quotient, we can call it as both. So if concentration quotient is greater than Kc, concentration quotient is greater than Kc. See, we can look at this diagrams here. See, two blocks are shown to you. One is representing Kc, other is representing QC. Another block QC, KC, here QC and KC. Now what you see, if QC is greater than KC, वो कौन सा situation है, ये देखो ये situation है, QC is greater than KC. Can you observe here? So here QC is greater than KC. In that case, what will happen? QC will try to attain or will try to become equal to KC. So here then QC will tend to decrease because QC is greater than KC. To make it equal to KC, it has to reduce. So QC will decrease, and QC decreases so that it can become equal to KC. Okay, and this can happen only if the reaction proceeds in the backward direction. So ye QC, if it is greater than KC, then it will try to reduce itself. Why? So that it can become equal to KC, and at that time the reaction should move in the backward direction. So we can predict that if QC is greater than KC, then QC will tend to decrease and the reaction will move in the backward direction. ठीक है? If QC is equal to KC, then the reaction is in equilibrium. ठीक है, दोनों ही सेम है, मतलब वो equilibrium attain कर चुका है. If QC is less than KC, if QC is less than KC, then this is the situation. So QC will try to increase so that it can become equal to KC. अब increase कब करता है? When it moves in the forward direction. So this situation is representing that reaction moves in forward direction. Okay, here you can write reaction moves in forward direction. Okay, in forward direction. ठीक है, here reaction is in equilibrium. This is reaction in equilibrium, and here reaction is in backward direction. Okay, it will be in the backward direction. Have you followed? So these are the three situations. QC क्या है? It is the concentration of reactant and product measured at any other time than equilibrium state. Okay, so you can write here concentration of reactants and products measured at any other time than equilibrium. Equilibrium में state में नहीं measure किया है, at any other time. Okay, so you will, that is what is called as the concentration quotient. Followed? So when you find QC like equal to KC, then we can say that the reaction is in equilibrium, and if QC is greater than KC, तो QC reduce होने की कोशिश करेगा. क्यों? So that it can become equal to KC, और वो कब होगा? When it moves in the backward direction. ठीक है, और QC is less than KC मतलब the QC will try to increase itself so that it can come equal to KC, और वो तब हो सकता है when the reaction will proceed in the forward direction. So this is the second application, कि predicting the direction of the reaction. Okay, note down. The third application of the equilibrium constant is for calculating the equilibrium concentrations. Now calculating the equilibrium concentrations means to calculate the concentrations of C and D. Suppose this is a reaction A plus B in equilibrium with C plus D. So C and D are the products which are formed, and you want to calculate the concentration of the products at equilibrium. Then using the value of Kc, we can find out the concentrations of C and D. That is what it means. Okay, so you can calculate the equilibrium concentrations. Suppose this is the reaction given to you. Say initial concentration of A is A moles, ठीक है, और B is B mole, and C और D तो initially there is no formation of product, तो उनका concentration will be 0 only. At equilibrium, okay, at equilibrium, what is happening? सपोज ए मोल में से x अमाउंट इज यूज्ड, B मोल में से भी x अमाउंट इज यूज्ड, then C and D will be formed which is x amount only. So equilibrium concentration will be what? A minus x for A, and for B it will be B minus x. ठीक है, and same amount, जितना amount A और B का यूज हुआ गया है उतना ही अमाउंट बनेगा ना for C and D. Okay, so x amount of C and x amount of D will be formed. This is the concentration of the equilibrium. Okay, here हमने मोल लिया है. Okay, these many moles. ठीक है, of A is being dissociated, मतलब इतना रह गया है. A minus x amount of x mole of A is remaining at equilibrium. B minus x mole of B is remaining at equilibrium. X mole of C is formed and x mole of D is formed. Understand? अब इक्विलिब्रियम में वी कैन पुट द Kc इक्वल टू, हम लिख सकते हैं ना, Kc इज इक्वल टू कॉन्सेंट्रेशन ऑफ C इंटू कॉन्सेंट्रेशन ऑफ D बाई कॉन्सेंट्रेशन ऑफ A इंटू कॉन्सेंट्रेशन ऑफ B रेज टू दैट स्टोइकोमेट्री. अब इधर हमने 1 1 1 लिया हुआ है, इधर जैसे A मोल से शुरू किया है तो हम इधर A लिख सकते हैं, इधर B लिख सकते हैं. ठीक है, सो A मोल्स ऑफ A, B मोल्स ऑफ B. ठीक है, रेज टू A आ जाएगा. इफ यू सिंपली राइट इट एज स्टोइकोमेट्रिक कोएफिशिएंट, यू कीप इट एज 1 ओनली. ठीक है, 1 mole of A reacts with 1 mole of B to give you 1 mole of C plus 1 mole of D. Suppose you have taken A mole of A and B mole of B, then initial में तो there is no product formation. At equilibrium x amount has been used of A and B, therefore A minus x amount of A is remaining at equilibrium, B minus x amount of B is remaining at equilibrium, x amount of x mole of, we can amount when I say it is mole. Okay, x mole of C mole of x mole of C is obtained and x mole of D is also obtained. So you can write Kc is equals to the C concentration into D concentration upon A into B concentrations terms we can write. Now what is C? C is x. ठीक है, C का अमाउंट कितना है इक्विलिब्रियम में? x है, इंटू D का अमाउंट कितना है? x है. ठीक है, x इंटू एक्स अपॉन A का अमाउंट इक्विलिब्रियम में कितना है? A माइनस एक्स अमाउंट इज रिमेनिंग. डोंट पुट द स्क्वायर ब्रैकेट, नीड नॉट, यू कैन सिंपली राइट इट एज स्क्वायर ब्रैकेट. ओके, A माइनस एक्स लिख सकते हैं एंड हियर यू हैव B माइनस एक्स. सो यू हैव this much amount of the reactants and the products at equilibrium. So you can write Kc is equal to x square upon A minus x into B minus x. तो इस तरह से जब हमें Kc पता है तो then we can find out the value of x. जैसे x is only the concentration of C and D at equilibrium. Okay, so you can find out that. एक सम करके देखेंगे, then you can understand it better. So we'll carry out or we'll do a sum. Okay, so let us do it. 0.1 mole of PCl5 is vaporized in a liter vessel. In a liter vessel मतलब 1 लीटर वेसल का वेसल में this PCl5 is evaporated. Calculate the concentration of Cl2 at equilibrium. So here the equation which you are talking is PCl5. Okay, it has been decomposed because we want to calculate the amount of Cl2. So that is PCl3 plus Cl2. Okay, so पहले देख लेना कि बैलेंस होना चाहिए रिएक्शन. Equation should be balanced. So you have, this is a balanced equation, so you need not multiply any number to balance it. Okay, so this is a balanced equation. First and foremost you should write the balanced equation, otherwise no, this x taking amount of, that is number of moles of the products, it will vary. So you be careful कि हमेशा इक्वेशन जो लिखें हम, it should be balanced. Okay, तो ये balanced equation है. कितना अमाउंट से शुरू किया? 0.1, मतलब इनिशियल कॉन्सेंट्रेशन इट इज 0.1 मोल है. ठीक है, इनिशियल में देर इज नो प्रोडक्ट फॉर्मेशन टेकिंग प्लेस, तो इसीलिए हम उसका वैल्यूज 0 लिखेंगे, ठीक है। देन एट इक्विलिब्रियम what will be concentration of PCl5? Let us take it as 0.1 minus x, मतलब 0.1 में से x amount has been used या decomposed, ठीक है। So how much amount of PCl3 will be formed? x amount. Cl2 कितना बनेगा? वो भी x amount बनेगा, ठीक है। जितना यूज हुआ उतना ही बनता है, ठीक है। So for this, how can we write Kc equal to? Kc is what? It is the equilibrium constant which is given by the product of concentration of the product divided by the product of the concentration of the reactant, isn't it? So Kc will be what? PCl3 into Cl2 इस तरह होगा upon PCl5, ये होगा ना Kc for this particular equation. So if substituting the value, what will you get? PCl3 का वैल्यू हमारे पास x है और Cl2 भी x है और PCl5 क्या है? 0.1 minus x है, okay. Kc value is given to you. See, equilibrium constant for the dissociation of PCl5, it is given as 0.414. So Kc value is given to you. That what is Kc? Kc is 0.0414. Okay. Now using this, we can put the equation as 0.0414 is equal to x square upon 0.1 minus x. ठीक है. Now just you multiply it that side. So what do you get? X square is equal to 0.1 minus x into 0.0414, ठीक है। अब मल्टीप्लाई कर लो, सो व्हाट डू यू गेट? एक्स स्क्वायर इज इक्वल्स टू 0.1 इंटू 414, दैट इज 0414 माइनस x इंटू 0.0414, ऐसे आ जाएगा। एक क्वाड्रेटिक इक्वेशन मिलेगा हमें। सो यू हैव इट दिस वे, एक्स स्क्वायर, इसको इस तरफ ले लेंगे तो माइनस 0.0414। ऑल ऑफ यू हैव कैलकुलेटर, सो यू नीड नॉट वरी। ये इधर माइनस था तो इस तरफ लेके आएंगे तो वो प्लस हो जाएगा, एंड दिस पार्ट विल बिकम व्हाट? हियर 0.1 इंटू 0.0414 है, सो दैट विल बिकम माइनस 0.00414, इस तरह आ जाएगा, विच इज इक्वल टू 0। यू गेट अ क्वाड्रेटिक इक्वेशन। क्वाड्रेटिक इक्वेशन का रूट्स फाइंड करने के लिए x इज इक्वल टू व्हाट? माइनस बी प्लस और माइनस अंडर रूट ऑफ बी स्क्वायर माइनस 4ac बाई 2a, ये फॉर्मूला अप्लाई करो। b हमारे पास है 0.0414, देन a is 1 and c is 0.00414. So using that, ये एक नेगेटिव वैल्यू आएगा और एक पॉजिटिव वैल्यू आएगा। यू विल गेट टेक द पॉजिटिव वैल्यू। नेगेटिव वैल्यू इट इज ऑफ नो यूज बिकॉज वी वांट टू फाइंड द कॉन्सेंट्रेशन ऑफ Cl2, वही पूछा है ना, व्हाट इज द कॉन्सेंट्रेशन ऑफ Cl2 एट इक्विलिब्रियम। कॉन्सेंट्रेशन ऑफ Cl2 एट इक्विलिब्रियम इज x, और x का वैल्यू नेगेटिव नहीं हो सकता, सो नेगेटिव वैल्यू यू डिस्कार्ड एंड यू गेट द पॉजिटिव वैल्यू। आई होप यू विल बी एबल टू डू दिस बिकॉज दिस इज जस्ट द सॉल्यूशन ऑफ अ quadratic equation. So now you understand how we can find the concentration of the product at the equilibrium state. Okay, so this is how you can, all of you should complete this. Okay, I have not completed. You can put the values and get the value for x. Put the value of b, a and c. Okay, do it everyone. Let us solve one more question based on it. See, value of Kc for a particular reaction is given to you as 4.24 at 800 Kelvin. Now, for the reaction CO with H2O giving you CO2 and H2, you are asked to calculate equilibrium concentration of CO2, H2, CO and H2O. तो सभी का concentrations you have asked to calculate. What is the reaction? Your reaction is CO, carbon monoxide, reacts with H2O to give you CO2 प्लस H2. पहले तो देख लेना है कि ये बैलेंस्ड है कि नहीं. इज इट बैलेंस्ड और नॉट. सी 1 कार्बन yes, ऑक्सीजन 2 है, here 2, here also 2, 2 हाइड्रोजन, इट इज बैलेंस्ड. ओके, इनिशियल कॉन्सेंट्रेशन दिया हुआ है, इनिशियल कॉन्सेंट्रेशन ऑफ CO एंड H2 ओनली इज गिवन. ओके, कितना है 0.1 मोलर दिया है. अब पिछले क्वेश्चन में मोल्स, इट वाज गिवन इन टर्म्स ऑफ मोल्स. इन द प्रीवियस क्वेश्चन दैट इज PCl5 decomposed to PCl3 and Cl2, there it was given in terms of mole, but the vessel was of 1 liter and concentration means what, moles per liter या moles upon volume होता है ना, N by V होता है, तो number of moles upon volume 1 था, so the concentration could be directly taken as the moles only. But here already it is given in terms of molarity, the concentration is given in terms of molarity, so here also we need not worry. दोनों का concentration 0.1 मोलर दिया हुआ है. Initially CO2 और H2O तो नहीं बनेगा, so take it as 0. Then equilibrium concentration, it will be 0.1. Let us say X amount has decomposed or X amount has been used of this CO, and 0.1 minus X of H2 is combined to give you X amount of CO2 and X amount of H2. ठीक है, अब ये इक्विलिब्रियम सिचुएशन है तो Kc हम लिख सकते हैं, Kc will be equal to what, concentration of CO2 into concentration of H2 upon concentration of CO into concentration of H2O, इस तरह से है. So what is it, X into X, क्योंकि CO2 और H2 का concentration at equilibrium will be X. यहाँ पे जितना यूज हुआ है उतना ही उधर बनेगा, प्लीज रिमेंबर दैट. And CO will be 0.1x into 0.1 minus x, sorry, 0.1 minus x into 0.1 minus x. Kc का value we are having with us. What is the value for Kc? Kc is given as 4.24. Okay, so using that we will just try to solve. Kc will be equal to what? X square upon 0.1 minus x the whole square. This is 4.24 into 0.1 minus x the whole square is equal to x square. Okay. Solving this equation, 0.1 minus x the whole square, so here we can since this is square, this is also square, we can take the square root of, on both the sides. So what we have, 4.24 into 0.1 minus x the whole square, which is equal to under root of x square. Square cancels out. 4.24 ka square root you should find out using your calculator, you can find out. So here x and square root of x and x square, it will get cancelled out. Here also square and the square root will cancel out. Here 4.24 no, uska square root you can find out, it comes out to be 2.06. You just use your calculator and you can obtain the square root of 4.24. It comes out to be 2.06. Okay, so 2.06 into 0.1 minus x, which is equal to x. इस तरह आ जाएगा. Multiply 2.06 into 0.1 into 0.1 आ जाता है, minus 2.06x is equal to x. Now this will become what? 0.2 है ना, ये point shift हो जाएगा to the left, 0.206. This minus 2.06 I take it to the other side, so I have 2.06x plus x. So this becomes, ये 1x है ना, तो this becomes 3.06x, 0.206. So your x value is 0.206 by 3.06 इस तरह आ जाएगा. Okay. So you solving this, you will get the value of x. It should come out as 0.067. Okay. So x is 0.067. Once you get the value of x is only the concentration of H2, x is only the concentration of CO2. So what do we have? Concentration of CO2 equal to concentration of H2, it comes out to be 0.067. You can write it as moles per liter or m लिख सकते हो, capital M. That is also showing you moles per liter. Also they have asked what is the concentration of Cu and H2, that is also asked. So what is the concentration of Cu and H2 at equilibrium? It is 0.1 minus x, 0.1 minus x. अब वो दोनों भी same ही है. So you can write concentration of Cu which is equal to concentration of H2O. It is equal to 0.1 minus x है. अभी x हमारे पास 0.067 है. So what is the value? You can just calculate and see what value you are obtaining. You should get it as 0.033 molar. So that is your answer. Okay. So this is how you can understand how we can find the concentrations of the reactants and the products at equilibrium. We can find out. So that is the third application of equilibrium concentrations. Few more questions based on this kind of thing, calculating the equilibrium concentrations, predicting the direction of the reaction. All this we will do it in the next section. Okay. So this time we have done how the Kc has different applications by which it becomes useful to us. Okay. So copy down.